Hello student, so welcome back to this video lecture. For this lecture series, I will be following the book, Numerical Problems in Geology, GATE and JAM, Mrinal Shreshtha sir की जो book है. So by the Mrinal Shreshtha, and this book is excellent for competitive exams like GATE, JAM, NET, SET, mining and other geological exams, geology examinations. So however one challenge may be all of you face कि जो ये इसके कॉन्सेप्ट हैं. सो कॉन्सेप्ट इन दिस बुक आर एक्सप्लेन इन अ वेरी कंसाइज मैनर, है ना. सो बिगनर ऑटन फाइंड डिफिकल्ट टू अंडरस्टैंड द बेसिक्स. So in this series I will explain every topic in the simplest possible language, starting from basics and gradually moving to advanced concepts. So even if you are studying, for example, today we are learning about remote sensing. So if you are reading first time remote sensing, you will be able to understand it comfortably. Okay, so let's start. Okay, so first question come in mind, what is remote sensing? So first let's understand the meaning of the word remote and sensing. Remote means far away. Just one second. Remote plus sensing. Remote means far away and sensing means collecting informations. So remote sensing means collecting information about an object without touching it. Okay, so for example, suppose you want to know about a mountain, so you can go there physically and study it, or you can use a satellite that takes picture from the space, and second method is called remote sensing. Okay, so simply क्या किया हमने, it is simply observing the earth from the distance, earth or whatever you want to study, so you observe that from the distance. Okay, remotely. So remote sensing remote sensing means collecting informations about an object without touching it. Now we will understand about how does remote sensing work. So now you may ask, how can a satellite know whether it looking at water, forest, roads, building? So answer is light. Sun sends energy. What is basic principle in remote sensing? Main energy source sun. So sun sends the lights to the earth. These are light beams, light photons. Okay. So some lights absorbed, some light reflect. Every object reflect light differently. Suppose there is rock, catch light and light get reflected. So each object reflect light differently. For example, water reflect light differently than vegetation, rock reflect light differently than soil, building reflect light differently than roads, satellite record this reflected light. We put satellite here and satellite records reflected light. This reflected light is called electromagnetic radiation. Light which is coming, also known as EMF spectrum. We will study about that later. So what is this? Waves are called electromagnetic radiation, and understanding it is foundation of remote sensing. Okay, so before that we will study some basic fundamental definitions. After that we'll move on to this part. Okay, so I hope book is visible now. Okay. First definition is wavelength. Lambda. What is wavelength? It is defined as the distance between two consecutive crest peaks or two troughs in a wave motion. So let's begin with this definition. Imagine you are standing near the sea. This is sea area. You are standing here. Okay. And you can see waves moving continuously. How waves move? Up and down motion. Like this. So each wave has top point. This is top point called crest, and each wave has top point that is called crest, and also has a bottom point that is called trough. Trough. The distance from one crest to next crest. This is one crest and this is earlier, or this is next. So trough. So distance from one crest to another crest is called wavelength. This distance is called wavelength. Or the distance from one trough to the next trough is called wavelength. So we can define it as wavelength is the distance between two consecutive crests or two consecutive troughs of a wave, and it is represented by Greek letter lambda. If the distance is large, we can say wavelength is long. So this distance large. So we can say wavelength is large or large wavelength. And when distance is small, wavelength is short. So in remote sensing, different wavelength help us to identify different objects on Earth. Okay, I hope you understand about the wavelength. Now let's understand about time period. What is time period? Capital T. It is the time taken by a wave to complete one cycle. So suppose one wave start moving, okay, and how much time does it take to complete one full circle? That time is called time period. For example, if we take one example, so if one wave complete one cycle in 2 seconds, then the time period is 2 seconds. We can take another example, like if you think about a swing. If it moves forward and then come back to the same position in 2 seconds, so its time period is 2 seconds. So time period is the time required for one complete wave cycle, and it is represented by capital T. And what is SI unit of time? As you all know, second. Okay. Now comes one of the most important concept about frequency. So what is frequency? It is defined as the number of wave cycles completed in 1 second. Its SI unit is hertz or second inverse. Frequency equal to 1 by T. What is T? T is time period of wave. So what frequency tells us? Frequency tells us how many complete wave pass on a point in 1 second. For example, you have this point, so how many wave comes to this point in 1 second? So suppose only one wave passes every second. If only this one wave passes every second, that means your frequency is 1 hertz. Suppose 5 wave pass every second, so your frequency is 5 hertz. How you write about hertz? Hz. I think there is right. Yeah, Hz. So higher frequency means more wave every second, and lower frequency means lower waves every second. The relationship between frequency and time period is frequency equal to 1 upon time period. This means if the time period increase, the frequency decrease. Whenever relationship between two things is inversely proportional, so if one will increase, another will decrease. Okay, so this is, I think, now clear. Okay, if the time period increase, frequency decrease, and if the time period decrease, frequency increase. They are inversely proportional to each other. Okay. Now we discuss about relationship. Oh, sorry, I forgot about wave number. So let's discuss about wave number. Wave number, it is defined as number of wavelength in a unit distance. So what wave number defined? It is defined as number of wavelength. That means how many wavelengths are present in 1 meter. It is simply the inverse of wavelength. Okay. What is the formula? Inverse of wavelength. So if the wavelength is very small, so many waves can fit into 1 meter. So the wave number becomes high. If the wavelength is very large, I can write it so understand properly. If wave number become high, then what is effect on wavelength? Wavelength is very large. Just sorry. If wavelength is large, you can understand like that. No? So if wavelength is large or wavelength is small, so how much waves fit in 1 meter? If you have wave 1 and wave 2, so which wave have higher numbers of wave? Yeah, higher wave number, wave 1 or wave 2. For example, this is 1 meter distance and same distance as we take in this. So one have higher number of wave numbers. Okay, why? In this case 1, there is how much wavelength we take? 1, 2, 3, 4, and in this 1 and half. Okay, so this is higher frequency. Okay, so if your wavelength is higher or increase wavelength, decrease the wave number. Or okay, so I hope some this is clear now. So therefore the wave number becomes inversely proportional to your wavelength. Okay. So in simple word, wavelength means high wave number and small wavelength means high wave number, and large wavelength means low wave number. Now we see relationship between electromagnetic waves, speed, its wavelength and frequency. So every electromagnetic wave travel at a speed of light. The relationship is c equal to lambda f. What is c? C is speed of light. That is all electromagnetic waves travel at the speed of light, and lambda is wavelength of light, and what is f is frequency of light. Okay. So the speed of light approximately, what is speed of light? 3 into 10 to the power 8 meter per second. Since the speed of light is constant, if wavelength increase, frequency must decrease. Okay, I tell you another example. If c has constant value and you increase lambda, what you need? Constant value of lambda into f. So if you increase lambda, you have to decrease frequency. Okay, so what I said, since the speed of light is constant, if wavelength increase, frequency must decrease. If wavelength decrease, frequency increase. This is one of the most important concept in remote sensing. So always remember, long wavelength, low frequency. Long wavelength equal to low frequency. Short wavelength equal to high frequency. Okay, next, now let's understand about photon. So as per the quantum model, energy is emitted in terms of pockets of energy called quanta. The particle of energy carried is called a photon, and each photon carries energy Q, defined by Q equal to H into F Hc upon lambda, where Q is expressed in joule, and what is H? H is Planck constant, which had this much values. Okay, so now understand this. Earlier scientists believed that light behaves only like a wave. Later they discovered that light also behaves like tiny particles. These tiny particles called photon. Okay. Think about rainfall. So rain is made of tiny water droplets. Similarly, light is made up of tiny pockets called photon. Each photon carry a small amount of energy, which is Q. And millions and billions of photons together form light that we see. What is Q? HF equal to H.C. So energy of photon. What is energy of photon? Does every photon have the same amount of energy? So answer is no. If someone asks you whether the billions of photons make light, so is all the photons have same energy? So answer is no. Some photons may carry more energy, some carry less energy. The energy of a photon depends on its frequency and wavelength. The equation is energy equal to H into F, where H is Planck's constant, F is frequency, C is speed of light, and lambda is wavelength. Okay, so just remember these two ideas. Higher frequency means higher energy, and shorter wavelength means higher energy. So if frequency high means higher energy, and shorter wavelength means higher energy. Okay, why? Because long wavelength means low frequency and short means okay. So for example, blue light has more energy than red light because blue light has shorter wavelength. Okay, and this concept is very important in remote sensing because different wavelength carries different amount of energy. Okay, and this is one example problem which is given in your exam, this book. The energy of a photon. Okay. So the energy of a photon with a wavelength of 550 nanometer is tested into 10 to the power minus 22 kilojoule. The speed of light is this much. Planck constant is this much. So round off in 2 decimal place. What you have to do? Simply put the formula and calculate energy carried by one photon. And this is your example. Okay. So as wavelength decrease, photons energy increase. Now we understand about finally total radiant energy Q. The total radiant energy Q is a beam or ray is a function of the number and spectral makeup of the photons according to the expression. This is the expression where sum is this signature sign is tell about sum. So where the sum is overall frequency is present in Ni, the number of photons at the each frequency Fi. Qi is energy of a photon at a frequency F1, and radiant energy Q is given in joule. So a single let's explain. I will explain this. So a single photon carries only a tiny amount of energy, but sunlight contains billions of photons. When we add the energy of all the photons, we get total radiant energy. So think about a classroom. One student, one clap, and the sound is small. But if 50 students clap together, the sound becomes much louder. Similarly, if one photon carries so little energy and millions of photons together produce a large amount of energy. Okay, so that total energy is called total energy radiant. Okay. So let's quickly revise today's lecture. Remote sensing means collecting information without touching an object. Satellite receives reflected electromagnetic radiation, and wavelength is the distance between two consecutive wave crests. Time period is the time required for one complete wave. Frequency is the number of waves passing in 1 second, and wave number is the number of wavelength per unit distance. Wavelength and frequency are inversely related. A photon is the smallest pocket of light energy, and shorter wavelength means higher photon energy. Total radiant energy is sum of the energy of all the photon. Okay, so this is the explanation of this page. Okay, so whenever I upload about this series lecture, so keep your notebook ready, and if you have this book, open it the chapter remote sensing, and then begin this lecture. Sorry, I have to tell this in beginning, but it's okay. This is for next lecture, and in the next lecture we will continue about radiant flux, irradiance, radiant extents, and radiant intensity, and radiance, and black body. Okay, so thank you so much for watching this video lecture, and if you want to attempt some quizzes related to other geology exams, you can follow the telegram channel which I pinned in first comment. So thank you so much for watching this video lecture, and very best for your examinations.